Next, we'll work problem 6.9, which deals with partial pressures. A 1-liter mixture of helium, neon, and argon has a total pressure of 662 millimeters of mercury at 298 Kelvin. If the partial pressure of helium is 341 millimeters of mercury, and the partial pressure of neon is 112 millimeters of mercury, what mass of argon is present in the mixture? So we have the partial pressures of 2 of the 3 components of a gas mixture and the total pressure. We also have the volume and temperature, so we can calculate everything that we need. So remember that previous relationships told us that the total pressure of a gas mixture is equal to the partial pressure of each of the components in the mixture. Right? And so we have the total pressure, we have the pressure of helium and neon, and from that we can calculate the pressure of argon. From the pressure of argon, we can get the moles of argon because we learned that the partial pressures have similar relationships to the ideal gas law as they do to the partial pressure equation. So the partial pressure of A is equal to the moles of A by the ideal gas law. Okay? And then from the moles of A, we can calculate the mass of that component. So we're going to do that for argon. So first, we calculate the pressure of argon from the other pressures. So the pressure of argon is equal to the total pressure minus the pressure of helium minus the pressure of neon. Okay? So the pressure of argon, the partial pressure of argon, is 209 millimeters of mercury. So we need to convert that to atmospheres before we can use the gas law equation. The ideal gas law equation says that the moles is equal to PV over RT. So that's equal to the pressure divided by R, which is the gas law constant, times the temperature. And we multiply that times the volume, which is 1 liter. And we get the moles of argon, which is 1.125 times 10 to the minus 2 moles. From the moles of argon, we can calculate the mass of argon through the molecular weight. The mass of argon is 39.95 grams per mole, and we get that from the periodic table right here. Okay, and so we get 0.449 grams of argon as our final answer. Now we can work the for-practice problem. A sample of hydrogen gas is mixed with water vapor. The mixture has a total pressure of 755 torr, and the water vapor has a partial pressure of 24 torr. What amount in moles of hydrogen gas is contained in 1.55 liters of this mixture at 298 Kelvin? Okay, so we know that the total pressure is equal to 755 torr. The partial pressure of water is equal to 24 torr. The volume is equal to 1.55 liters, and the temperature is 298 Kelvin. All right, so we know that the total pressure is equal to the partial pressure of hydrogen plus the partial pressure of water. So the partial pressure of hydrogen is equal to the total pressure minus the partial pressure of water, which is equal to 755 torr minus 24 torr, right? Which is equal to 731 torr. Now we need to convert that to atmospheres. So the pressure of hydrogen in atmospheres is equal to 731 torr, and we know that 760 torr is 1 atmosphere. Okay, so that is equal to 0.961842 atmospheres. All right, now we can use the ideal gas law equation. N is equal to PV over RT, which is equal to 0.961842 atmospheres times 1.55 0.55 liters divided by 0.08206 liters atmospheres per mole Kelvin, that's our gas law constant, times 298 Kelvin. So that's equal to 0.0610 moles. All right? And our problem says, what amount of moles of hydrogen gas is contained in this mixture? So we have our final answer.